Hello. Okay. Ah, I'm never sure if I'm actually live. Can somebody in the chat tell me like if I'm, you know, actually live? And I'm not sure what's going on the screen. What can you guys see? Visible? Wow. And audible? Is everything fine? We can hear. Wow. So I think it's right over here somewhere. I tried to add the chat into this. I'm not sure how well it's going, but yeah. Ah, so this contest. Ah, I got stuck at the last problem. I mean, I do have a very good idea of this, and I'm pretty sure it will work. But I don't know why I was getting idleness limit exceeded. Probably some small bug or something. I tested it on local, and like I was able to get the right answers on the local, but like here it's giving idleness limit exceeded. So I don't think it's a silly mistake because I've done Endel everywhere. So probably that's not the issue. But yeah, I'm not sure. I do have the idea, like theoretically, I know that it's definitely gonna work. Uh, Hi everyone. Hi. Okay. Mm. Okay. So anyway, so how was the contest? I really liked one of these problems. I think it was Wolf or Goblin. I don't remember. Yeah, Goblin. Goblin was actually very nice. I really like this problem. Um, yeah, we're gonna do solutions for all of these problems. Like from we're gonna do G as well because like um, we're gonna do G as well because at least I know um, like at least I know how to solve it theoretically. Code wise, I think I messed up. Maybe out of practice for a long time. Yeah. Okay. Let's start. Right. Let me actually open one of these. I can do only 4 by 8. Yeah, so A was actually pretty easy, but um, there's a callback. So A and F are actually pretty similar. Like not similar, but they have the same story, sort of. And then there's a different problem. But yeah. Okay, so free version. Right. So we simply have a string like 1 0 1 0 0 1, something like this. And then what we do is we form a grid sort of thing by flipping one of these bits in every string. So like in the first string, the first bit will be flipped and the others will remain the same. And then in the second string, you will flip the second bit. Then in the third string, you will flip the third bit and so on, right? So this will become 1, this will become 0 and so on. And what you want to do is you want to, I guess, count the number of ones that are present on this board. So what you can see is that every time there's a 0 in this entire column, there will be exactly 1 in the 0 column, and in the 1 column there will be exactly n minus 1 ones. So you sort of have to you have to do n minus 1 multiplied by the frequency of, I think, yeah, multiplied by the frequency of 1 plus the frequency of 0. So this is sort of like the answer. And if you look at the code, chat looks awfully quiet, I guess. But yeah, so if you look at the code, something like that I've done. It's like yeah, so I have n, I have the string, I iterate on the string on all of the characters. Now this value is c minus 0, so it will be 0 if the character is 0, and it will be 1 if the character is 1. So if it is 1, then I multiply it by n minus 1, and if it is 0, then I simply add it. So if you take the summation of this thing, it will just be the frequency of 0 added by the frequency of 1 multiplied by n minus 1, and then you can just print that. Yeah, easy peasy, I guess. So now we can move to the second problem. The second problem, yeah, so I think this one immediately clicked when I read the problem. To me, it immediately clicked, and I'm not very sure how to explain, how to come up with such a solution. But yeah, so the problem is something like you have a permutation, and then there's a why don't you? So yeah, in B test case, okay, I think I'll read the chat in some time. Yeah, so the you're given a permutation, and then oh, so actually, so the funny thing is that I have placed the chat somewhere here, like above me, and like when I'm actually reading it, it's on a second screen, which is like below. So I'm pretty sure it looks weird, right? I'm looking below to read the chat that's above. Uh, if I, okay, actually, if I move my uh, photo above, then like it will make more sense, right? I think I can do that. I think I can do that. If I unlock this, I can probably move myself up and then move the chat down. Okay, hello. Right. So now when I'm reading the chat, does it look like I'm reading the chat? Okay. Yeah. Wow, this is good. Okay. Top coder above newbies. Lol. Ah, jokes apart. So yeah, we have a permutation. So you like, since this is B problem, a lot of you people who actually got stuck at this might not know things like what's like permutation. I think everybody knows, but yeah, what's mex? I think you probably don't know that, and you'll have some confusion around that. So like it's it's harder to have some intuition around mex because you're like seeing it for the first time. But yeah, okay. So I guess let's start with the explanation of the problem itself. So like you have, so permutation is simply any order of 0, 1, 2, 3. Like from 0 to n minus 1, you can make it in any order. So that's the permutation. Now max is like it's the minimum excludent. So it's like the smallest element that is not present in a set. So for example, if I have 0, 1, 4, 5, something like this, so the max is actually 2. So it's the smallest non-negative integer which is not present in this set. So you can see that 0 is present, 1 is present, but 2 is not present. So it is the max or the minimum excludent. So excludent means what is not present, and minimum is minimum. So yeah, so that's what max is. And we sort of have to make a permutation such that the painted color is maximized and the paint is done in a way that yeah. So like if you have a permutation 0, 2, 1, 3, something like this, so they will paint it in the order of the max. So for example, here the max is 1. Then here also the max is, like for these two also the max is 1. Then for these three the max is 3, and here the max is 4. So something like this, the paint will be done. And what you want to do is you are given a certain number, and you want to maximize the number of occurrences of that in this painted thing. So my idea is to get that value as quickly as possible. So like how to get x as quickly as possible? What you can do is you can simply have the permutation go like 1 2 3 4 5 dot 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 till x minus 1, right? So this way, if you look at the paints, they will be 1 2 3 4 dot 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 till x, right? So that's the quickest way to get x, right? Because if you want the max to be x, you need x elements, you need all of these elements. So that's the quickest way to get x. Now I want this x to stay with me for the longest time. So how can I do that? I can do that by not including x in this set. So what you have to do is you have to place x at the last position, and then everything else you can fill anywhere here, right? So fill anything in between. And yeah, so if you fill anything in between, then the paint will be x for all of these values, and at the end it will always be n. So you can't change that. It will always be n for the last element, right? Now so what do we fill here? So the easiest way is to fill it n, n minus 1, n minus 2, dot dot dot, and so on till x. So I guess if you look at it code wise, that's sort of what I've done. Just print from 0 to x, print in increasing, 0 to x minus 1, print in increasing order, and from n to x, print in decreasing order. So this is a macro that I've made. It is simply for int I equal to a and smaller than b. So it's like from 0 to x, 0 to x minus 1 basically. I print it in increasing order, and from and after that I print everything in decreasing order. So that works. If I show you the test details, these are the type of permutations that I print. So my answer, if you wait a second. Yeah, so from 0 to 2 I printed in increasing order, and then 4 and 3 in decreasing order. So that's how like that's the type of permutations that you have to print. Okay. It is in your solution. Why so many questions? Why don't you post on Utkarsh Gupta channel? Yeah, I think so. I think there are a lot. So I actually have another YouTube channel. If somebody doesn't know, so actually, I'm actually kind of famous, by the way. So yeah, so I have another YouTube channel which has a lot more subscribers. I don't know, maybe close to, I don't remember, 80,000, 79,000. Yeah. So you can see I actually have another YouTube channel with around 70-80,000 subscribers. Hi guys, this is going to be my competitive programming journey video. I know that people have been asking for it since the last 1 year, but finally I'm going to make this because I don't want to lose the opportunity of titling it like how I became India rank 1 on Codeforces, because yeah, right now I am India rank 1 on Codeforces. Just became that yesterday. I will be telling how that happened. So yeah, let's begin. So first question is how I learned programming in the first place. So I learned programming because I was like really interested in audience, I guess. Oh, sorry. I just closed it. Fuck, sorry. Ah, I didn't know. Is it okay now? Wow, okay. Anyway, so what I was saying was, I'm pretty sure. So basically, my laptop is muted, but my desktop audio is still being captured. So maybe that's why this happened. Am I audible? Hello. Yeah. I think this should go 0. Yeah. Okay. So anyway, so I was saying that I have another YouTube channel, and accidentally the audio was on and you guys were hearing noise, I guess. But yeah, so what I was saying was that I don't post there because there are a lot of subscribers there, which followed me maybe 3 years ago, and I might not be relevant to them right now. So I don't want to, give bell notifications and all that to thousands of people who don't even find these videos relevant. So that's why I have a second smaller channel. And like what does it even matter? We'll soon grow to that point anyway. So yeah, then it will be the same thing. Has the problem discussion been started? Yeah, we are at problem C right now. We've already done A and B, so you can maybe rewind and see those if you're interested, or you can directly watch C or come later if you're interested in like E or F or G. I don't know. Yeah. Um, cherry bomb. I actually forgot what this problem was. Yeah, okay, I remember. So, right. So we are given two arrays and they are called complementary if at every position the sum of the corresponding elements is same, and basically some in some places like they have given you array A, and in array B they have left blanks in some spaces, so they put -1 instead of the actual values. But yeah, audio is too low. I think audio should be fine. I'm using a mic. Can I show this? I'm actually using like a huge mic. Should be fine. And the audio is like full, so it should be fine. Yeah. Wow, nice. So anyway, basically two integer arrays are complementary if the sum at every position is equal, and they have given us the array A and B, but in B they have removed some of the elements, and yeah, so all the elements should be between 0 to k. So there are non-negative integers not greater than k, so all elements have to be between 0 and k. So some of the elements are lost, and you want to find the number of ways you can fill the blanks such that these two arrays are complementary, and you still stay between 0 to k. So yeah, again let's start. So what's kind of happening here is that you have two arrays, and at every position you want these two to have the same sum as these two, as these two, as these two, and as these two. Yeah, there can be three cases, like I don't know how to arrive at this, but like intuitively I saw three cases. So one case is that there are all -1s, so we have all -1s. Then the second case can be that we have some -1s, and the third case is obviously that there are no -1s, right? So these are the three basic cases. uh, who's exorcist? Speed up, yeah. So there are three basic cases. Like I'd love to speed up, but then there are some people who must have been stuck at C, and you know it shouldn't be irrelevant to them. So anyway, if everything is -1, then there can be multiple ways. So there can be multiple ways of filling it, or zero, like zero or multiple. Then if there are some -1s, then there can only be one way at max. So at max there can be one way. And if there are no -1s, then again there can be one way or zero ways, right? So now zero ways just means, so actually these two cases are not that different, they are a little different, but yeah, for this case you just have to check whether your two arrays are complementary or not. If they are complementary, then your answer is 1, otherwise it is 0. Now what about this case? So in this case, since there are some values present in B that are not -1, so with that value you can add it with this one and kind of get the sum. So you can get the sum which is fixed, and you sort of have to ensure it at every position. So what you will do is you will check at every position that if this value is present, then these two should have the same sum as this, and if it is not present, then you have to fill, if you have x here, so then this value has to be sum minus x, right? So you have to check that this should be in the range 0 to k. right? And if it is true for all elements, then you have one way of doing it, otherwise you just have 0 ways. Okay, so I think that is pretty straightforward. You don't need to think about minus one and no minus one separately. You can combine them. Yeah, I did combine them in the solution, but then like while thinking, you can think of them independently. But yeah, so anyway, so now what do we do when we have multiple minus ones? Like when we have all minus ones. So when we have all minus ones, then you don't have a fixed sum. Then the sum could be anything, right? So the sum could be anything, but it has a range. So it can never be greater than the like it can never be the smaller than the max element, right, of A. So it has to be greater equal to the max element of A. So basically there are some restrictions on the sum. So you can say that the sum is always greater equal to the max element of A, because these values cannot be smaller than 0. So whatever wherever the max element is present, if you add 0 to that, the sum must be the maximum greater equal to maximum of A, and it is also uh, smaller equal to, so it is also smaller equal to K plus the minimum of A, right? Because in the minimum of A you cannot add anything more than K. So this way you have some restrictions on the sum, and every value between these will work. So you just have to count the number of unique values. So that's what I've done. If we see in terms of code, so I have A and B, then I have the minimum and the maximum, and also the minimum and maximum of B, right? So minimum and maximum of B were actually not required, but I sort of used it like if the maximum of B is -1, then all of them are -1. It's like a hack actually. But yeah, cheap trick. But anyway, like I thought this was quicker. Like I didn't want to make a set and insert everything into the set and make sure that everything is -1 or not. But anyway, so anyway, if we have all the elements as -1, then the like it has to stay, like the sum has to stay between minimum plus k and maximum. So the total number of values between these are minimum plus k minus maximum plus 1. So we're adding plus 1 because like both are inclusive. And like if this is smaller than 0, then you have to max it with 0, like because like you never have to print a negative value, right? So that's why we do this. But anyway, now otherwise if there are if we have the other two cases, then the answer is 0 or 1. So first of all, I find an element that is not -1, and the sum is just the sum at that index. Right now, at any position, if you don't have a -1, then that sum has to be equal to the sum from the outside. Otherwise, you set a Boolean variable to false, and if that value is -1, you sort of have to fill some minus a there, and that's the required value, so that has to be between 0 and k. So if it's smaller than 0 or greater than k, then again you set that Boolean variable to false, and if it's true, then the answer is 1, otherwise it is 0. Let me check the chat now. You can combine them. So as you can see that I actually have combined them in my solution. This is not lead code, it is Codeforces. Okay, yeah. Check where not -1 something something. Okay, how do you solve so fast in the contest? Actually, like these days I'm pretty slow. I used to be at least 2x faster when I was in practice. So I haven't done a lot of CP in at least, I don't know, maybe 3 years. So I'm very slow now. Okay, yeah, my code's logic was exactly the same. Yeah. Oh, oh, but anyway. Okay. Right. So should we move on to problem D now? Do you have shortcuts or macros you recommend? Yeah, I do have a lot of macros in my code. Like you can probably recommend something from there. Oh, sorry. If you look at my code, I have some code for ordered set, like these two lines plus these few lines are for a structure called ordered set, and then I have some more defines. Like instead of pushback, I just write PB. I don't know. I find it easier. And then to input an entire vector, I have a macro. Like I have some extra macros to do stuff. But yeah, should we move on to problem D? Oh, hi Samarth. Are you Gupta Sam? I remember you from Discord, I guess. But anyway. Oh, nice. Oh, D was hard. Nice. So let's start with D was hard. Nice. Nice. Such a nice. Wow. Okay. Wow. But yeah. Ha. At least somebody got my joke. Okay. So first time seeing my role model live streaming. Wow. You didn't watch my old streams? Things you gotta to make content these days. Yeah, I hope I don't go viral. Or I hope I do. But like this was not. D was nice. Yeah, I bet you liked it. Hello, brother. Nuclear Teddy. Rating of 420. Wow. 420. Nice. Uh, yeah, I guess we've had a lot of D jokes. Now let's actually go to the D problem because these D jokes you can do it in every contest. Like every contest generally has a D. Some contests actually have D1 and D2. So you can do some DP in that case. But anyway, let's start with the problem. So there's a flower boy. Oh, I don't know. Again, so this problem, I guess, if you don't get the idea instantly, you can spend maybe I don't know. You can spend hours trying to figure out what to do here. But like, I guess if it clicks, it clicks. Like for me, I got the idea as soon as I read it, and then I sort of found a way to like it's a very nice technique in which you can kind of uh, improve the code. Like you can write half the code uh, that you're supposed to write, right? So like that's a very good thing. Binary search, I don't know, I don't think this is binary search, but anyway. So like the idea I used was pretty simple, and like if it clicks, like for me the moment I read this problem, it was like pretty obvious what we have to do here. So anyway, stuck in D got stuck. What? Anyway, yeah. So yeah, so you have n flowers, and then they have some beauty. So since this is D problem, I'm not gonna over explain it. I'm gonna go a little faster now. Is that okay with everyone if I go a little slightly faster than the previous three problems at least? So anyway, we have 69 concurrent viewers. Okay, sorry, 71. But anyway, so you want to collect m flowers, and to do so you can walk from like left to right and choose whether to connect a flower at this position or not. And the ith flower must have beauty bi. So you have n flowers. Out of those you have to collect m, and the ith flower has to have the beauty bi, and you have the entire array. I think this one I was able to do a little faster than the others. Okay, no, I think I took 11 minutes, which is fine, I guess. Way out of practice, so it's fine. But I remember I got the idea immediately upon reading this. So yeah. Anyway, I think that's what the problem is. Yeah, so you want the minimum integer such that um, sorry, yeah. So you have a magic wand. You can place one uh, you can place one flower anywhere of any beauty, and you want to find the minimum integer k such that the flower that you put in between is of the beauty k, and it should ensure that you are able to collect m flowers. Okay, 11 minutes for you is 11 hours for us. Ah, you're just flattering me right now. But yeah, so how many of you are watching this mainly for problem D? Like, for how many of you the D was the determining problem of this contest? Like, you were able to, solve C and then you got stuck at D, or you were able to do D at the very end or something like that. How about using meanies? I think this problem was pretty simple. Like, you don't have to use anything special for this. Maybe a little special, I don't know. But yeah, nothing too special here. So you're sort of given two arrays. One is array A, the other one is array B. I'm watching for D. Yeah. I'll show you. Don't worry. But yeah. So you have problem A. This has the beauties of the flowers, and you have the array A, which has the beauties of the flowers, and the array B, which has the required beauties, I guess. So I guess I'll read the chat after explaining this. But anyway, so you sort of have to move from left to right here and keep picking the flowers. If they are, like, beautiful enough, then you pick them, and then move to the next position at the array B. So one simple observation is that you can do this greedily. So uh, like, not the entire problem, but just the flower picking. So go to A and then see if this is sort of greater or equal to this. Like, if this value is greater or equal to this thing, then you can pick this flower and move here. If this is smaller, then you go to the next. This is smaller, then you go to the next. If this is greater or equal to this, then you go to the next one here and here as well. Then if it is smaller, go to the next. If it is greater or equal to this, then go to the next one, both of them. Right? So pretty simple. It's simple, greedy. Just move from left to right here, and if you can pick the flower, then pick the flower and go to the next index on B. Right? So that's pretty simple. That's pretty obvious. But uh, how do we put a flower in between? So, like, it's very hard to come up with if you don't know it already. And I think it is one of those problems that if it clicks, it clicks. So the observation here is that I don't know if I even thought of this first or not, but I kind of thought of the fact that we can do the same greedy thing from right to left as well. So right, so like, you can move from right to left on the B array as well as the A array. I don't know if it's obvious to everyone or not, but you can move from right to left as well. So yeah, anyway, so you can move right to left here and right to left here as well. So you can do the same thing, and if it's possible to do it from left to right, then it will also be possible to do it from right to left. I don't know if I can prove this, and let me know in the chat if it is obvious to you, or if you think we should be proving this. But yeah, to me it is obvious that instead of moving left to right, we can also move right to left, and if left to right works, then right to left will definitely work. Yeah, I think it is, like, pretty obvious. But yeah, so while you're moving left to right, let's say if you have reached a certain index, like, let's say we've reached till here, we have covered the first four flowers, and we find out that out of these first four, we can pick two of these. So we have traversed this much, and we can pick two of these flowers, right? So we can store something like this, right? We can store this, like, uh, here we can only pick 0 flowers, here we can pick 1, here we can pick 1, and then 2, then here we can also pick 2, then 3, 3, 3, 3, and so on, right? So it's something like, if I move from left to right, uh, let's say I can't pick this flower, so we can only pick 0 flowers. If I can pick this flower, then this is 1 flower, and then I can't pick this flower. I can pick this flower, I can't pick this flower, can pick, can't pick, can't pick, can't pick, and so on, right? So we can have a sort of array like this. We can number how many flowers can we pick if we start here. But we can also do it if we start from right to left. So we can also start from right to left, and we can store that as well. So let's say we can't pick this flower, we can pick this one, we can't pick, can't pick, can pick, can pick, can't pick, can't pick, and can pick, right? So we can have these values from right to left as well. So we get 0 from here, 1 from here, and then again, 1, 1, 2, 3, 3, 3, 4, right? So like if we move from left to right and we're at a certain index, how many flowers can we pick? And if we are from right to left, if we're at a certain index, how many flowers can we pick? So we can have an array like this, right? Now in total, you can see in total there are 1, 2, 3, 4, 5 flowers. So in total we want to pick 5 flowers. So at any point, you see, if we look at this position, I don't know how obvious this is, but if we look at this position, you can see that I can pick 2 flowers till here. So I can pick the first 2 flowers here, and I can pick the last 2 flowers from here, right? So we can pick the first 2 flowers from here and the last 2 flowers from here. So only the third flower we won't be able to pick from anywhere. And if we if we insert a flower in between here, then we are able to pick everything, right? Yeah, so I don't think, some people are saying, I don't know, binary search, mean heap, something, but like according to me, this is just prefix suffix sort of thing. So if somebody is joining just right now, calc is short for calculator. But anyway, so let's say this is the prefix and then this is the suffix, right? So if you are at a certain index, you can see that this value gives you how many flowers can you pick from the left, and then this value gives how many flowers can you pick from the right. And in total, if you can pick, like if you add these two, if you get exactly m minus 1. So if you get m or anything greater than m, so then k is just 0, because you don't have to add any flower here, and simply you can pick 2 flowers from here and 3 from here, and it's fine. But if you get exactly m minus 1, then what you can do is you can pick the first 2 from the left, the last 2 from the right, and this flower you'll have to add. So you can sort of like whatever this value is, for example, if this is 100, so you can add a flower of k equal to 100, and k equal to 100 is one of the answers. So you'll iterate on all of these positions. Wherever this condition is true, you sort of have to have the minimum of this. So that's the idea for D. And I did a pretty cool thing in terms of implementation. So instead of writing the code twice for this suffix prefix, I made a lambda which just gives you the prefix. Okay, so I have a lambda which gives you the prefix. So then what I do is I first get the prefix, then I reverse both the arrays, and then I again get the prefix. But now the prefix becomes the suffix because you have reversed the arrays. And yeah, again, so, and then I reverse it again so that the suffix is like correct, so yeah, this is a very nice technique. You can do it for array problems and grid problems, like whenever you have to do something from 2 directions. So instead of doing it from 2 directions, you can just do it from 1 direction and then reverse the whole thing and do it again, do the same thing again. So you don't have to write the code twice, and you can simply do it once. So this part, this function, like this is something like 2-pointer itself, but I have implemented it in a different way. But yeah, it is something like 2-pointer. It's just the greedy thing that I'm doing. But yeah, so I have the prefix and the suffix. Let's say I have done the reverse magic, whatever. Let's say you don't want to do that. You can do it anyway. You just compute the prefix once and then write the same code again, copy paste it, erase, do your whatever nonsense, and that way you have the prefix and suffix both. So yeah, now at every index, I can see how many total flowers I can pick. Like from prefix, I can pick this many flowers, and from suffix, I can pick this many flowers. So if the total flowers are greater or equal to m, then the answer is 0. If the total flowers are equal to m minus 1, then the answer is the minimum of b of prefix of I. So like from the left, if I can pick 6 flowers, then the sixth index of b is the beauty of the flower that I need to insert. So that's what it is. I'm going to read the chat now. If anybody has any doubts, now's the time to write those down. Okay. I came to watch you. Wow. And you came to watch the D as well. Okay. Uh, okay. Got stuck in D, me, ching chong. Wow. Okay. Thank you. Thank you. Oh, fuck. I fucked it up. What could be the rating of problem D? Uh, I don't know. It's very hard to judge. Very hard to judge what could be the rating. Like for me, I think for me it was pretty easy because like to me it clicked immediately upon reading the problem. But I do understand that if it doesn't click for someone, then it can take a lot of time. So it's sort of like a greedy sort of thing, greedy prefix suffix. I don't know, maybe uh, so I'm old also. Like I have my standards are from 3 years ago, so things have changed. But I don't know. I put it somewhere between, I don't know, maybe 1700 or 1800. Like 1800. I'll bet 1800. So I think D was around 1700. I think 1700 should be the rating for this one. Oh, sorry, but this is Div 3. Div 3D cannot be 1700, right? Doesn't make sense. So because the rated people are below 1600. So I don't know. Maybe then, but I think Div 3 Gs are high rated, right? I don't know. Div 3 Gs are generally 1900 something, 1900, 2000. But yeah, I think these should be at least 1600. 16 to 1700 is what I'll guess. Yeah. Anyway, sorry. I think I was still reading the chat. I just now realized, yeah, sad. E was 1200. What was E? Yeah, E was, I think E was pretty easy. Maybe a little bit more towards implementation, and no, I think there are some things you can kind of mess up while doing E. So yeah, E was I think, I don't know, maybe again 16, 17, 16, 1700. Not sure. 1200, 15, 1600, 1500. Not expert level for sure. G will be 2100. I think so. Yeah. I think the implementation was a little harder. Theoretically, I definitely have the solution. But yeah. Is your username demoralized? Yeah, I think you can see it here. Yeah. Also, like maybe here. Okay. Anyway, let's go. Okay. Should we start? Levi Ackerman. Oh, I remember you. Nice. Hi. Speedrun on leak code problem? I don't know about speedrun, but I think this Saturday I'm thinking of doing the lead code bi-weekly contest. I'm thinking of doing a screencast for that. Yeah, I remember you, Levi Ackerman. Like I remember there was some, you're from some anime character. I haven't watched the animes even now, but I remember there was someone like that. I have no idea what's going on here. Maybe that's why I'm unemployed. Wow. Haha. Depends in which stream you are. Like if you're a doctor and you're watching this, uh, definitely you have the answer why you're unemployed. AOT. Oh, I should watch AOT. A lot of people have asked me to watch AOT, but I haven't watched it. Should we start problem E? How many people got stuck at E? Like for how many people E was the contest defining problem? Oh, nobody wants to watch E. Wow, nobody is here for E. So I think I'm just gonna do these fast so that maybe the future viewers can see it. You want to? Okay, nice, 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 nice. Oh, by the way, anybody watching, I guess you should subscribe also, because I'm planning to do these streams or screencasts or solutions, something of most Codeforces rounds. Like, I do have a job, so it's harder to promise that I'll do it for all of these contests, but I'll try to do it for most, like at least, I don't know, at least 70% of the contest, I'll try to do it. So yeah. So you have a permutation, already subscribed, great. Winners. You have a permutation, you want to perform binary search on it. I think I've seen a problem like this before, but yeah. So what they're saying is that this permutation is not sorted and you're still doing binary search on it. And if you're doing a binary search on it, what's like, will it give you the correct answer or not, right? So it gives you the correct answer. Like you sort of, I'll show you the simulation. So yeah, if it doesn't give you this correct answer, you can repermute the, I guess you can repermute the array in some way, but you can't move the element. You can't move the element which is to be found, right? So you are given L, R, and K. So yeah, inside the range L comma R, they're trying to find K on a permutation, on not a sorted array, right? So you can't move the element which is K. Like you can't move the element where K is present, but you can move everything else, right? So how many ways are there to sort of make sure that no, sorry, not how many ways, right? So how many minimum number of positions do you have to change so that like you can choose a number of indices and you can repermute them. So what is the minimum number that you need to repermute so that the binary search can be successful, right? So simply what will happen is that you have a range L to R, right? And then you perform a binary search on it and you want to end at the position K. Sorry, not the position K. You want to end at the position inverse of K, right? So inverse K is nothing but it's the inverse permutation. So it is like inverse of Pi equal to I. I'm writing diagonally. Inverse of Pi is just I. So you start off here and you want to end at this index. So you want to do the binary search, like this is the M. So from, like, you'll definitely be at this point. From here you want to go to the left, then let's say you go here, then again you want to go to the left, and if you're here you want to go to the right, and if you're here, okay, this is the correct element, right? So you kind of have to simulate this. So what I did was, let's just say id equal to inverse of K, and now I will use binary search to sort of find this id itself. So this way I will have M equal to L plus R by 2. Now if this is present in the left or right, you sort of go to the left or the right, and this way you get all the important points, right? So this is one of the important points, then this is an important point, this is an important point, this is an important point. Maybe this is not an important point, I can ignore this one, but yeah, let's say if we go like this, here, then here, then here, then here, right? Then these three are important points. So you need to collect all the important points, and you sort of have to know where you went from the important point. So like from this one, you know that you go to the left. From this important point, you go to the left. From here also you go to the left, and from this one you go to the right. Okay, so if you can keep track of the important points and whether you went to the left or to the right from that important point, you can keep track of how many elements between in this range, like out of these important points, how many elements you need bigger than K and how many you need smaller than K. So for example, this element has to be bigger. So you need a bigger here, you need a bigger here, and you need a smaller here, right? So you can you can count how many biggers are needed and how many biggers are needed and how many smallers are needed, right? And then you can also check if this value is actually already bigger, right? So if this is already bigger, then you don't have to do anything about this. And then like if this is already smaller, you don't have to do anything about it. So you can keep track of how many extra biggers are needed, how many extra smallers are needed, and then how many extra biggers you have, how many extra smallers you have, and then you'll repermute them amongst themselves. So I think if I show the code, then that will be easier to explain. Okay. So yeah, simply n and q, I have a vector p, input the permutation and mark the inverse permutation. Now you have L, R, and X. Now I have how many biggers are needed, how many smallers are needed, how many biggers are used, how many smallers are used. The ID is the inverse of X, found is false, but yeah. Now I do the binary search. The binary search is to simply find the ID itself. Like if m equals ID, then found is true, break. If m is smaller than ID, then L plus 1, otherwise R minus 1. Now you also kind of have to keep track of how many like yeah, so if you want to go to the right, so if you're going to the right but this value is small, so a small is used here. But if the value is big, then a small is needed here. Similarly, if you're going to the left and this value is bigger, then a big is used, but if it is smaller, then a big is needed, right? So you now have these values, whether the value is found or not, how many bigs are needed, how many smalls are needed, and then how many bigs are used and how many smalls are used. Anyway, so now whichever one is needed, you sort of have to repermute it, because if it is needed, you have to change this position definitely. And obviously if it is not found, then the answer is just -1. So if it's not found, then the answer is -1. If it is found, then you can do something. So yeah, so if big, so whatever needed are there, both you have to sort of change. Now you can see that all the small needed can fill the positions of the big needed, because small needed means that a bigger value is present here while a smaller was needed, and big needed means that a smaller value is present here while a big was needed. So they kind of cancel each other out, right? So if you have 3 big needed and 4 small needed, you can kind of subtract that and get 1 extra, right? So you only care about the extra. Now since the big needed is greater than the small needed, I have this extra condition. I'm not sure if this was even needed or not, but I wrote this condition. So available big is how many big are actually present. So X is the input. It's actually K, I guess, but I wrote X. But anyway, so in the entire array, there aren't more than n minus X values that are greater than X. And out of those, this many are already used. So you definitely want the available big to be greater or equal to the big needed. Oh yeah, this condition is definitely needed, because you see, if K is like if K is equal to n and big needed is greater than 0, then there's no way to do it, right? So yeah, so that's why this condition is also needed. So available big is how many values are present that are not already used, that are bigger than K, and big needed is how many you want to fill. So if that's true, then answer is total plus extra, otherwise answer is -1, otherwise you can't do it, right? And similarly for small, it's like more or less the same thing. Small minus big, and then you count how many smalls are available and how many are needed. So that's it, and that was probably me. I should read the chat now. Already subscribed. Reason for coming back. How's life at Graviton? Do you need big? Ah, wow. Anyway, so yeah, I'm starting YouTube again after a long time because like I think I kind of always wanted to do it, but I wasn't able to make time. So now I am kind of managing to make time. Um, like I don't know how long I'll be able to manage it, but at least for now I'm kind of able to manage it. So that's that. Can you please show how to approach lead code mediums? I think you can watch my Saturday's videos. On Saturday, there's a bi-weekly contest on lead code. Um, I'll probably do a screencast for that, so you can watch that. And yeah, definitely subscribe if you want to get those notifications and whatever. Yeah. So how many are watching so far? F is actually very interesting and can you please explain problem D? You can, rewind maybe, I don't know, 20-30 minutes ago. I was, oh, didn't understand the optimization. What was D? Okay, it was just, are you talking about the prefix suffix thing? Came to watch F. How many are here to watch for F? Target now in CP? Probably, I don't know. I'm not sure if I want to, target CP. I'm trying to focus more towards content. I don't know. I do want to be Grandmaster again. The red color looks good, but I think it will take a lot of practice, and probably I don't want to do that. Like my schedule doesn't allow that. So that's that. Yeah. Okay. So I think some people are still watching for F, and F is a very interesting problem. I really like this one, and I was doing it without pen and paper, so it got a little tougher for me. But yeah. So it's a callback to the problem A actually. So in problem A, we had this thing that we have a string like this, for example. Let's say if we have a string like this, it's too long string. I want a smaller string. So yeah, if I have a string like this, you make a grid from this string by changing one character at each position. So we have 0, 1, 1, 0, 0, 1, and then 0. And the rest you fill as it is, right? I think you can fill it like this. Uh, and then I guess one. I actually made this. Wow. Anyway, so now what they want you to do is they have some sort of connected. They have a grid like this. I should have made the grid first. Okay, I think there's a 0 here. Right, so you have a grid like this, and basically there are some connected regions in here of zeros, and you sort of have to find the biggest region. You have to print the size of the biggest region. For example, I think here you have 3 plus 3 is 6. Here you have 4 and 2, and I think this one is the biggest. It has 4 plus 6, 10. So 10 is the answer here, right? So how many of you were able to figure this much out? Like how many of you were able to figure out that this is what we have to do? I think this is just the problem statement, right? I did it using DSU. Yeah, that's the solution actually. That's what I did as well. So anyway, So the problem here, the only problem here is that you can't actually make this grid, because it will be n cross n, and then that will be n square, and it will be big. So what we can do is, you can see that there are 3 regions in every column. So in every column there are 3 regions. For example, if we look at this column, so you can see there's one region, there's a second region, and there's a third region, right? So there are 3 regions in every column. In this column also there's one region, second region, and third region, right? So you can connect these parts with each other, and you can sort of figure out how these are connected. So whenever we have a 1, you can see that its middle part is connected to the lower part of the previous one, right? So this is the lower part of the previous one, and this is the middle part of the one. So you can see that the lower part of the previous one is connected to the middle part of the one, right? And in case of 0, you can see that 0, the upper part connects to the upper part, and the lower part connects to the lower part. And in case of 0, 1, you can see that the upper part connects to the middle part of the previous, right? So I think these are the cases that you have to think of, and that's it. So you have to make 3 different parts for each 0 and 1. So for the one case, you can see that the sizes of these sets are 0, 1, 0, because you have no zeros here, you have 1 0 in the middle, and you have no zeros here. And for the 0 set, then the sizes become oh, is this even visible here? Let me check. A little less. Oh fuck. Yeah. I did undo in the wrong window. Wow. But yeah, is everything still fine? Is the stream fine? Can anybody let me know in the chat? Okay. So the upper part has I elements, the middle part has nothing, and the lower part has n minus 1 minus I. Fine borders, yeah. So actually I have nothing here. I have empty space here. So I tend to write here, but I shouldn't, because I have I am present here, and then I have the chat below me. Yeah. Anyway. So yeah, basically 0 will connect to the middle part of the previous and the lower part of the previous. Oh, sorry. Wait a second. 0 connects to the 0 upper part connects to the upper part, lower part connects to the lower part, and also the upper part connects to the middle part. In case of 1, you can see that just the middle part connects to the lower part. So that's what you have to do, and I did it using DSU. I can show the code here. Let me show you on Codeforces itself. So I have a struct for DSU. It has a vector for parent and size, I guess. So this is not the size of the this is not number of nodes. This is like this size. Okay. So now in the constructor, I fill the parents, and the sizes I set them to 0 to begin with. Then this is merge and find. I wrote it during contest, so that's why I just wrote path compression. I didn't write union by size or rank, anything like that. Plus this size is different. You can't union by this size. You'll have to maintain another size or rank to do that. But I think n log n works here, so I didn't go into that hassle. Just union by path compression optimization is enough to get login. Okay. Now I have an int n and a string s. I take n and s, and then this is so for DSU I make 3n nodes because you can see that I have 3 sets for each of them, and then I set the sizes of these nodes first. So you can see that yeah, so xyz is 3i plus 1 and 3i plus 2. So the sizes are if it is 1 then 0 1 0, if it is 0 then I 0 and n minus 1 minus I. You can see I 0 and n minus 1 minus I. Then yeah, then I again iterate. This time I start from 1, so I have small x, small y, small z are the 3 sets for the current, and the capitals are the previous ones. So I connected them accordingly. Like if it is 0, then I connect the top with the previous top, and the bottom with the previous bottom, and the top with the previous middle. And if it is 1, then I merge the current middle with the previous bottom. So those are the things that I've done here. You can see uh, current middle with the previous bottom. So this is current middle with the previous bottom. Then top with top, bottom with bottom. Also top with previous middle. Yeah, top with previous middle. So all these cases have been covered. So along with this DSU, I also have kept track of the size. Then you just have to find the set with the maximum size, and that's the answer, and that's what you print. That's it. What kind of work do you do at Graviton? That's very confidential. But yeah, it's mostly C++ stuff. Yeah. So G1 I'm actually skipping. What I'll cover in G2. Basically G2 will cover both G1 and G2. So I don't know, due to some reason I wasn't able to get AC on this. I spent a lot of time on this actually. I think maybe 1 hour. I don't know. Yeah, more than 1 hour I spent on this, but I wasn't able to get an AC here. But I think I got the idea pretty quickly, and I'm going to explain the idea. You can try to implement it on your own. I can't show you the code, but yeah, the idea is actually pretty simple. Like maybe not too simple, but yeah. So in this problem, you are given a tree. I'll just go over it quickly. I do have a Discord server, but like it is not open for everyone right now. I will open it up after some time maybe. I'm trying to do some experiment with a smaller audience. Like if it works well, then that's good. Oh, by the way, if you're still watching, you can like this video so that others can you show your LeetCode account? I'm not sure if I have a LeetCode account. I mean, I do have a LeetCode account, but probably not logged in. Let me just log in and get back to you. I don't even know how to log into. Oh, wait a second. Does Google login work? Oh, it works. How do we see this? Yeah, I don't even have a proper username here. It's called user 858 something something HD. At least I'm in high definition. So you can see that I haven't done a lot of LeetCodes. I have done some contests though. How do we see contest history? Oh no, not this. How do we see contest history? Can anybody tell me how to see the contest history? Contest history. Where can we see that? Does anybody know? My contests? Contest, then is there a my contest? Oh, my contest, yeah. I have done a few, like in all contests, I have done like all the problems generally. So, yeah. Actually, I think I used to do videos for lead code also, if I remember correctly. Let me see. Is the desktop audio still on? I'm not sure though, because I'm not sure. I can mute it from here. Okay. I used to do, I guess, lead code problems. I used to explain while solving them, and I think I'm going to do this Saturday as well. I'm going to do the bi-weekly. So you can see I explain the problem, then I write the code. So it can kind of help you understand how to build your intuition. I do this for Codeforces also. Today I'm doing a stream, but yeah, generally I used to do this. This is my more um, like this is the format I do more often. Okay. I guess getting back to this problem now, we have a tree. We don't know where the root is. The root can be anywhere, and it's definitely not a binary tree. It can be any sort of tree. Yeah, any sort of thing can happen, right? What you want to do here is that you kind of have to. So these queries, etc., are given like you can probably read it on your own. Um, Fu is the sum of the values written on the path from root to the vertex, and then all values are 1 or -1, and you can flip those values as well. So you have to guess the values at every node, right? So guessing the values at every node will be easy once you sort of uh, figure out what the root is. Okay, so if you figure out what the root is, after that you can just do this query with the one node each, and you can get the path sum from root for all of these. So like you can get this sum, you can get this sum, and so on. What you can do is you can do a DFS from the root, and you can assign parents to all of these vertices. Also, let's say, like, for simplicity, let's say this is the root. So this way you will get like if you have values for all of these, like here and here. So the value present on this will be the fu minus f of par u, right? So you just need to know what the correct parent is, and with that you will be able to get the correct values in n queries. So let's say we use n queries to get these things, and we use the other 200 queries. So you have n plus 200 queries in total. So what you will want to do is you will want to use the other 200 queries to find the root, right? So root can be anywhere. So you have to find the root. How do we find the root? So there are two simple ideas here, and you have to sort of use a combination of those to uh, get to the correct answer. But yeah, so one thing is that let's say if we have any edge, let's say if we have this edge, and we want to figure out if the root is on this side of the edge or if it is on the this side of the edge. Like, you know, we can go to one of these sides of this edge by using three queries. How can we do that? So let's just say these are the two nodes A and B. So we just ask for FB, then we flip A, and then we ask for FB again. Now if these two values are equal, so if these two values are equal, then that means that the root is present closer to A. But if these two values are not equal, then the root is present somewhere here. So the idea is, if you can if you can do something like this, just do FB, then flip A and then do FB again, then check if these are equal or unequal. So if these are equal, if these two values are equal, then the root is closer to B, and if they're unequal, then the root is closer to A. So what you want to do is you want to cut this edge now. You cut this edge, and you have two different trees. You have this tree and you have this tree. So yeah, now if you're in this tree, so you can go to one of these trees, right, by cutting this edge. So you have to find an edge which cuts the tree in half, right? So if both of these are close to half, like let's say, I don't know, if this is close to n by 2 and this is also close to n by 2, something like that is happening. Maybe not exactly n by 2, it could be, I don't know, this could be n by 4, this could be n by 2 minus 20, and then this could be n by 2 plus 20. I don't care. Like if it is close to half, you can do this, and then you will, be in a subtree that is closer to half of the original tree. And by doing this, log n times, so in 3 log n, you are sort of able to get the root, right? And after finding root, it is easy. But this won't work always, right? Because sometimes there might be an edge where like sometimes there's no edge that can divide the tree into two equal parts, right? So what do we do in that case? Okay, so in that case, it will look something like this. So you will have a node that is having multiple children, and none of those has the size greater or equal to half, right? So let's say all of these have the size, let's say this has n by 3, like this has n by 5, this is also n by 5, this is also n by 5, n by 5, n by 5, n by 5, right? So kind of, if you look at this tree, so there are like this as the subtree proper, right? So if you look at this tree, there is no edge where you can cut it and kind of get like you cannot cut it into half by like there's no such edge. So what do we do here? So from this point we can pick one of these, right? How do we pick one of these? For this you can do another binary search. What you can do is so basically either this is the root or one of these has to be the root. Okay, I think I missed the case where this was the root. Yeah. Okay. I think I missed the case when this was the root. I didn't include that in my code. That's why I was getting wrong answer. But yeah, either this is the root or one of these is the root. I think if I still change it, I might be able to get AC. I still might be able to get somewhere here. Let me just break. This should work. Maybe that's what I was missing, but I'm not sure. Like it could still be wrong. But yeah, anyway, so then you can sort of do a binary search on these on the adjacency list of this. So basically, to check if the root is present in one of these, what you can do is, I think I'm still wrong. Yeah, probably. But anyway, so what you can do is you can uh, check the sum of all these and then change the value here and then check the sum again. If the root is present somewhere inside this, what will happen is that so if the root is present inside this, what will happen is that the value that is changed, like for all of these, uh, like if the root is outside, for all of these, you can see that the answer will change by 2 in the same direction. Like it could be -2 or +2. So if you take the number of these elements and then like whatever the answer has changed, if you take the difference of that and then the absolute and divide it by 2, that will be the number of nodes that that don't have a root here, and like that has to be equal to m. That's what you have to do, right? So if this is the case, then that means that all of them are this, I guess it should have worked, but I don't know. Like I am doing something wrong in the code. I'm not sure what's wrong with the code, but this is it. You just have to do a binary search here, and this way you will be able to get like which element is the root, like which element, which subtree has the root, or this element itself could be the root if you're not able to find anything. I guess that's the solution. FU while speaking loudly. Wow. Uh-huh. Is it DFS? DFS is too slow. DSU. My God. Okay, we had read these. Back from the dead. Yeah, I'm a phoenix. Okay, so I guess that's it for the stream. If you want to, chat some more on the live chat, I can be here for like 2-3 more minutes and then I'm gonna go have my dinner. Wow, average view duration is like 6.5 minutes, which is good, I guess. How to become a quant? I don't know, man. Why would you even want to become a quant? I wouldn't want to be a quant. Those people are kind of depressed. Make money, yeah. Yeah, maybe money is worth it, maybe not. I don't know. Hella money. Yeah, true. True. Maybe like you can kind of be depressed for like 3-4 years and then never have to work again. So makes sense. But yeah. I don't know a lot about how to be a quant, but like in general, I guess a background in like basic things like coding, machine learning, maths, and all those things, probability, statistics. If you're good at all those things, you can um, interview for quant positions, quant researcher, quant analyst roles in different firms, and you can climb the ladder from there. What role are you in? I'm actually a low latency C++ developer. So we do work closely with the quants, but our work is different. Yeah. LLM developer be better than LLM developer. You mean vibe coder? Vibe coders. I think vibe coding will, like, to be honest, I mean I specialize in C++, right? So I'm a C++ guy and I do a lot of C++, and I'm very proficient in C++. I can write C++ very quickly. but I'm actually very bad at Python. So, like I generally, whenever I have to use Python for work or, you know, if I'm working with a Jupyter notebook or if I'm doing some personal mm, machine learning project, like I rarely do those. But yeah, if I'm doing something like that, then I can uh, just use, like if I want to, make a uh, graph for, uh, I don't know, in matplotlib. So it's like I can just ask, I I have a data frame with I have a data frame with I don't know, um, minimum cost column. Sorry, I have a data frame with cost comma with columns like cost and I don't know, date. Make a graph for date versus cost. I mean, it can do a lot more than that. I can have I have columns like cost one, cost two, dot dot dot, cost n, and a date and date. So for every date at x axis, plot all costs, something like this. I think I can do something like this, and it will just like I will have to read a lot of Stack Overflow documentations and everything. I don't know about matplotlib, but it will just give me a simple thing like, okay, just do this and it will work, and it will work, right? So that's good. Yeah, so every cost column it will give me, and it will make a line graph for all that. I can ask it to do some changes. So yeah, vibe coding is good, but then I think your logic is still uh, necessary. Like you need to know what to write, and you need to be able to read this once and kind of understand if it's correct or not, because it does make mistakes a lot of times. So yeah, it's mostly like that. You can't rely 100% on AI. You can rely on it for writing the codes, for helping you with the libraries and all that, but that's it. You're not printing question mark for queries. What the hell? Shit. Is that why? Ah, what the hell? What the hell? Shit. Ah. Oh yes, I need a question mark for the queries. It can still be wrong. I might be exceeding the query limit. Sorry, the number of queries limit I might be exceeding. There might be some other issues also. Wrong answer immediately. Wow. Uh, what expected integer but question mark received? The hell? Oh, this, I guess. Okay. Something else is also wrong, so I don't know. But yeah, I'm pretty sure the idea is correct. Guess the wrong value. Wow. Wow. Okay, maybe I guess the wrong root then. That's why the value is wrong. It can only be wrong if the root is wrong. If the root is correct, then it can't be wrong, right? I don't know. Let's leave it. We can move past that. But at least I got past test case one, so that's a good thing. Uh, I mean, people who specialize their niche in developing LLM. Yes, yes. That I think that has the maximum scope in today's day. Like most startups are getting investment there, and AI is the new big thing. So yeah, definitely. Yeah. Luckily, that was not the only issue. Does your job require same level of creativity and brain usage expected from a GM on CF? Um, like so in on jobs, a lot of problems are like all problems are actually open-ended. So you can have a solution that just works, or you can have a solution that is like very, very good. So so that's the difference. Like you can write a okay solution, like which is fine, which is not too good, but it kind of works. But then you can also have a very good solution. So like yeah, so there are cases where I have used my the skills that I've acquired from my Codeforces Grandmaster experience, whatever, and using that I have like for example, let's say there's some function and you want to make it faster. So you can make it 10% faster, or you can make it 300% faster, right? So these are very open-ended problems, and like if you're more talented, if you're more if you're more skilled, then you can do better in those. Otherwise, you can do an okay job. So that's what it is. Do you play chess? I'm very bad at chess, by the way. I played a few times, but like I think I played for a month continuously, but I'm like very bad at it. I'm close to, I don't know, 1300 in rating on chess.com. Yeah. Can you explain how your team trained for ICPC? We didn't train for ICPC at all. We were just like we were individually good, so the team sort of managed to work. But yeah, that shouldn't have been the strategy. We should have practiced contest, team contests, and all that. Should have done it, but we didn't. What resources you used during your CP practice? Not a lot, honestly. I used to just mostly do the Codeforces problem set for practice, and then to learn something, I had this website called CP Algorithms. CP Algorithm. I had this website called CP Algorithms. You can what the fuck? Yeah, you can learn a lot of what the hell. I'm hiding this. Yeah. So there are a lot of algorithms that you can learn from here. Like for example, you can learn binary exponentiation. And then there are a lot of things. Like I think this has actually increased now. In my time, there were limited things here, but yeah, now there are a lot more things here. So yeah, you can learn a lot of concepts here. This is calculating the determinant of a matrix by Gauss. I'm not sure even if I know this. In n cube, I can definitely do it. I determinant in n cube. Determinant in n cube. Math. I think we triangulate the matrix or something. Is it like that? Diagonal matrix. Yeah, we make it a diagonal matrix. Okay, yeah. In n cube, it's easy, but yeah. Anyway, so you can do a lot of things. A lot of concepts are there in graphs. You can see there are different flows related things here. Maximum flow, MPM algorithm. You have min cost max flow. Uh, these are very advanced topics. You probably never see any problems related to these on uh, Codeforces contests, but yeah, maybe for ICPC and all this might be relevant. This is like LCA, binary lifting. So yeah, apart from this, you can also take help from Codeforces blogs also. Like I learned a topic called segmentary beats. I can't find it here. Maybe on Codeforces I can find it. search like this. GD2. I think by GD2 there was a blog. Yeah, GD2. So you can read these blogs also. These are some more complicated things. But yeah, for definitely there are a lot of blogs for easier stuff as well. So that's that, I guess. What else? 1300 is greater or equal to 95 percentile. Yeah, but 95 percentile is still very bad, right? Like in terms of CP, I don't know. I'm at a much better percentile. I don't know. One time I compared, I found the percent. Does it show percentile? Probably not. I think there's a bot named TLE on uh, Discord which shows the percentile, and like mine was 99.6 or 96. I don't remember. But yeah, so 95 percentile is bad according to me. Yeah, but I spent years and years on competitive programming and not that much in chess. So I don't know. If I do chess for 3 years day and night, then maybe I'll reach 99 percentile or something. I don't know, but like right now I'm at a like I'm not a good chess player. Mhm. What's the PBC coding contest? PBC coding question? Humble AF. I mean, it's not about being humble. I think this is more cocky. I'm saying that 90 percentile, 95 percentile is nothing. So I don't know. But yeah, I think I'm gonna end the stream now. I have got to go to my dinner. So bye guys. Anybody still on the chat can say bye. Oh, product based company. Uh, I guess 1900 plus is the safe range to be. You can get into those with a lesser rating also, but 1900 plus is kind of safe. 2100 plus is like very safe. Then your career is set. I'm not sure. Is there anyone who's 2100 plus and like struggling with a job? I'm not sure, but yeah, 2100 plus is like your career is set, I guess. You're like you probably won't starve, is what I think. 1900 plus is like you're in a safe range. I was 1900 plus in my prime. Yay. Okay. So bye guys and good night.